All right, so these are called reduction potentials. So these are standard reduction potentials. And this is a table of standard reduction potentials at 25 degrees C. And so obviously the temperature is going to have a role. Since temperature is not standard, we specify the temperature as 298 Kelvin. The standard reduction potentials go like this. When we look at it, what has the highest standard reduction potential? Well, it looks to be fluorine. Fluorine has the highest standard reduction potential at plus 2.866 volts. What has the lowest standard reduction potential? Lithium ion has the lowest. Actually, I think I know what it is. Minus 3 volts. I'll just show you. Minus 3 volts. And so lithium ions plus an electron goes to lithium solid. This is negative 3.040 volts. And so does the negative mean it's not a reduction? No, a negative, what does a negative mean? You tell me. Negative means that it has a standard reduction potential less than H plus. The reduction potential of H plus is 0 volts. And so, in other words, the higher the reduction potential, the stronger the oxidizer is. So this is the strongest OA. The lower the reduction potential, it's going to be weaker. So this is the weakest OA on the chart. There could be weaker OAs than this, but on the chart this is the weakest. And then hydrogen ion is somewhere in the middle at 0. And so these are all oxidizers. It's just how we write it. Now, because of the conjugate relationship, this is what we have. I should have given myself a little bit more room. The conjugate relationship is this. Fluoride is going to be the conjugate reducer of that. And lithium metal is going to be the conjugate oxidizer. And so the conjugate relationship is lithium solid is at the top. This is going to give us lithium plus an electron. These are going to be standard oxidation potentials. If we look at the standard oxidation potential and we look at the E naught here, then this is going to be 3.040 volts. This is going to have the highest oxidation potential, which means it's going to be, in other words, this has the highest potential to be oxidized. Over here, this has the highest potential to be reduced. And so high potential means something. It means something. It means that it is the most likely to be oxidized or reduced. Whereas if you start throwing in this negative sign and start to change things, then it gets all mixed up. So the lowest oxidation potential would be fluoride. This is least likely to be oxidized. And the oxidation potential for this is negative 2.866 volts. Hydrogen will have a 0 oxidation potential, not because it can't be oxidized. It's just because it's arbitrarily defined as 0. Right? This is arbitrarily defined as 0. And then to use these is very simple. When we use these, this is it. E of the cell, one leads to an error one way, the other leads to an error the other way. So E naught of the cell is just equal to the anode, which is where oxidation occurs, plus the cathode, which is where reduction occurs. And so we just add up those two potentials. So high oxidation potential means it's easy to oxidize or easier to oxidize over there. A high reduction potential means it's easier to reduce over here. And we just add them up. And we don't have to do anything weird. And so let's do the previous problem that we looked at earlier. And the previous problem was this. Well, previous problem is we'll go with E naught of the cell, and we're looking at the zinc. So this is Zn solid, right? But this is Zn solid goes to Zn2 plus. And so this is what we call the anode, or the oxidation. Plus E naught of copper 2 plus goes to copper solid. This is what we call the cathode, or reduction. So Zn goes to Zn2 plus. Let's see if that's on this one. Zn goes to Zn2 plus. Is here. Zn goes to Zn2 plus is minus 0.763 volts. Yeah, that's the slide here. So E naught of the cell, this is Zn goes to Zn2 plus is, what did I say, minus 0.763 volts? Plus the other potential. The other potential is copper 2 plus goes to copper. So let's look for that one here. Zn, oops, I did something. I made a mistake. Let me fix that mistake. Negative 0.763, is that the right one? Because what we're looking at is Zn goes to Zn2 plus. This is the couple we want. But when I look at this, this is Zn2 plus goes to Zn. Zn2 plus goes to Zn is negative 0.763. I don't want that. I want Zn solid goes to Zn2 plus. If we go Zn solid goes to Zn2 plus, then what we have to do is we have to change the sign. This is going to be plus 0.763, not negative, because we're doing the reverse reaction here. When we reverse the reaction, we're going to change the sign. And so this is not negative, this is positive. Petrucci would just leave it negative, right? And then he changes the sign by adding a negative in there. I don't. And I'd like to write the anode on the left. Cathode on the right, just as a habit. Now, do we have the same problem with copper 2 plus? We don't have the same problem with copper 2 plus. Where's copper? Because here we're going from copper 2 plus to copper metal. That's plus 0.340 volts. So this is plus 0.340 volts. And so this gives us 1.103 volts. 1.103 volts is what the cell measured. Let's go take a look. The cell measured. .103 volts. So Zn goes to Zn2 plus 0.763 volts, plus Cu2 plus goes to Cu, which is plus 0.34 volts, equals 1.103 volts. Well, all this time for just a simple equation, just this plus that. This is a simple equation. All right, let's take a look at what I'm going to have to do is, since we're out of time, right, what I'm going to have to do is I'm going to have to put some, in fact, I'm going to put chapter 20 on the final exam. The final exam is not going to be like half chapter 20 and 24 and 25. It's going to be a sprinkling of extra questions, extra multiple choice questions on chapter 20. And so why don't you guys work on, let's see what I've covered so far. I've covered 1, 2, 3, 4, 5, 6, 7. One through 7, for sure, you should be able to answer now. And 17. 1 through 7 and 17. Work on these now, okay, and see if you can do that.
So if you're going to include chapter 20 into the final exam, is the homework still due for that?
No, the homework will be due on the day of the final.
Okay.
And so chapter 20 homework is due final exam time. Okay. You also have chapter 24 homework, but that's not very long, and chapter 25, which is not very long. Final's cumulative, so all the chapters.
So is chapter 24 going to be in the final exam?
Well, chapter 20, I always have chapter 24 and 25 on the final, just as a few extra questions. It's just chapter 20 I don't like to put on the final because I want to see drawings. And the final I want all multiple choice, or so I might make a little drawing, make you do a little drawing.
So the final
yourself.
exam, does it consist all of multiple choice?
Mm-hmm.
There's no FAQ whatsoever?
Well, there's going to be some chemical reaction bonus questions on there. But that's it. On the final. Chapter 25 is just a brief survey of nuclear chem.
Are we going to get to that after 20? After chapter 20?
So our only last full exam is next week.
Yeah, chapter 19. I might change the point of distribution. Chapter 20 stuff you still, have to know.